Hey everyone, and welcome. Today, we're going to dive deep, and I mean really deep, into the world of marine biology, but probably not in the way you're thinking. We're going to explore how something as simple as a category on a spreadsheet can literally be the difference between a reef thriving or a conservation effort completely failing. So let's just get right to it with a huge question. Could a simple math error, a really simple one, actually destroy an entire coral reef? It sounds like something out of a movie, right? But stick with me, because by the end of this, you're going to see just how a tiny misunderstanding of data can lead to some massive, real-world disasters. All right, so here's the game plan. We're going to start with a story, a researcher's big dilemma. Then we'll break down the two main types of data you'll ever encounter. After that, we'll climb something I like to call the measurement ladder. And then we'll tie it all together to see why getting this stuff right is so important for the planet. And yeah, how getting it wrong can be, well, a catastrophe. Okay, so let's start with the fate of our reef and this hidden danger that isn't lurking in the water, but inside the numbers themselves. So I want you to picture this. You're a marine biologist. You're out in the field. Maybe you're on a boat surrounded by this incredibly beautiful, complex reef. And you're collecting data on everything. I'm talking species diversity, water quality, fish populations, coral health. It's like trying to solve this giant living puzzle. But here is the absolute key. What if the way you're looking at that data, the way you're analyzing it, is just fundamentally wrong? This isn't just some mistake on a paper that gets you a bad grade. If you, say, incorrectly average your coral health rankings, you could trick yourself into thinking a reef is getting better when it's actually about to collapse. This is where the stakes get just unbelievably high. So to keep from making those kinds of mistakes, we have to go all the way back to square one, back to the very first, most fundamental choice any researcher has to make, figuring out what kind of data they're even dealing with. And it really breaks down into two main camps. On one side, you've got qualitative data. Think qualities. This is stuff you describe, right? Like the species of a coral or what the seafloor is made of, sand, rock, whatever. Then on the other side, you've got quantitative data. Think quantities. This is the stuff you can count or measure, like how many fish are in a school or the exact temperature of the water. So qualities versus quantities. That's the first big fork in the road. Okay, now, once we know if we're dealing with qualities or quantities, we can start to place our data on what I love to call the measurement ladder. It's got 4 levels, and every single step you take up this ladder gives you way more power to analyze what you found. And these are the 4 rungs on our ladder: nominal, ordinal, interval, and ratio. The best way to think about them is like building blocks. Each step you climb up inherits all the features of the one below it, and then adds a new, crucial power. And trust me, understanding this progression is the key to doing good science and avoiding that disaster we talked about. All right, let's start climbing. The first 2 rungs, that's nominal and ordinal, they deal with our qualitative data, the categorical stuff. So at the very bottom, the absolute foundation of our ladder is the nominal scale. This is as basic as it gets. It's really just about naming things, putting them into separate buckets. Think apples and oranges. There's no order to it. One isn't better or bigger than the other. They're just different. So if we go back to our reef, this would be things like the species of coral you're seeing, acropora, porites, whatever, or the kind of fishing gear you spot. You can count how many nets or spears you see, but you can't logically say a net is somehow higher than a spear. They're just different labels. Okay, let's take a step up to the next rung, the ordinal scale. Now, this is where things get a little more interesting. The ordinal scale takes those named categories we just talked about and it puts them into a meaningful order. It introduces the whole idea of a rank. For our marine biologists, this is a huge deal. Now they can rank the health of a reef from poor to excellent, or they can classify how many fish they see as rare, common, or abundant. We know that good is better than fair, right? But here's the catch. We have no idea by how much. The distance between those ranks is totally undefined. And that exact limitation, not knowing the size of the gap between the ranks, is what pushes us to make that big leap up the ladder into the world of quantitative data, where we can finally start measuring those gaps. And this quote just hits the nail on the head. With ordinal data, you just cannot assume that the jump from poor to fair is the same size as the jump from good to excellent. To do that, well, you need a much more powerful tool in your toolkit. And that brings us to the interval scale. Now we're talking. Here, not only is the data in order, but the distance, the interval between any 2 points, is equal and it's meaningful. The best way to think about it is like a ruler where all the little tick marks are perfectly spaced out. But there's one tricky part. There is no true zero. The textbook example, and it's a perfect one, is temperature in Celsius, something our biologist is measuring all the time. We all know that the difference between 10 and 20 degrees is exactly the same as the difference between 70 and 80 degrees. It's 10 degrees. But that zero on the scale, it's a bit of a phantom. Let's dig into what it actually means. See, 0 degrees Celsius doesn't mean no heat or the absence of all heat. Nope, it's just a point we all agreed on, the point where water freezes. And that's the critical limitation here. Because there's no real starting point, you can't make ratio statements. You just can't say that 20 degrees is twice as hot as 10 degrees. It doesn't work that way. For that kind of power, we have to climb one last rung. To get there, we have to reach the top of the ladder, the ratio scale. This is it, the most powerful level of measurement. It's got everything the others have. It has order, it has equal intervals, plus it has the holy grail, an absolute zero. And a true zero means a total, complete absence of whatever it is you're measuring. So to find a real zero, let's forget about temperature for a second and grab something else from our biologist's gear, a scale. Let's think about measuring the weight or the biomass of a fish. Because 0 grams means exactly what you think it means. No fish, no biomass, nothing. And because we have that absolute starting point, now we can make those powerful ratio comparisons. We can say with 100% confidence that a 200-gram fish is twice as heavy as a 100-gram fish. This just opens up a whole universe of powerful statistical analysis. Okay, so we made it to the top of the ladder. Now, let's bring this all back down to our coral reef and see exactly why getting this right can mean life or death for an entire ecosystem. Because this is exactly where those dangerous traps are laid. A researcher, maybe they're rushing, might take those poor, fair, good rankings, which we know are ordinal, and they'll assign numbers like 1, 2, and 3 so they can calculate an average. That is a huge mistake. It's treating ordinal data like interval data, and it creates this completely false and totally dangerous picture of a reef's health. Or, even worse, they might take super precise fish lengths, that's powerful ratio data, and just dumb it down to small, medium, large, throwing away all the crucial details that could have warned them about a crisis. So let's just boil this all down one last time. It's really about this simple progression, right? Nominal just gives us names. Ordinal puts those names in order. Interval makes the spaces between them equal. And ratio, at the very top, gives us a true zero. Each step up that ladder unlocks new power, but it comes with one golden rule. You can never, ever apply the math of a higher rung to data from a lower one. That's the mistake that puts our entire reef in jeopardy. And that really brings us to the final takeaway here. This isn't just about fish and coral reefs. This measurement ladder, it applies to everything. Economics, medicine, sociology, literally anywhere data is being used. So I'm going to leave you with this question. Now that you can see this ladder, where else in your world is data being used, or maybe being misused? Because once you see it, you really can't unsee it. Thanks for taking this deep dive with me.